Okay, so I've got here the walls set up in a very basic way, and I'll maybe just quickly add in the fire escape. And because I've used the approach for the other walls having one set of walls for each level, I'm going to continue with that approach here. So I'm just going to put in walls following my reference planes, and then adjust the ends so that they're connected properly. And now I can simply copy and paste those walls. This time I'll show you a different option. You can use align to selected levels and choose the other floor. And then again, just check the top offset there. So again, using join to tidy up the graphics there. Right, so that's the basic shell of the building, and now I'd probably look at getting a floor in. So if you have a building like this, which is essentially sitting on a slab on the ground, you could normally just do a floor going to the outer edges of your walls. So I'm going to, as I'm making the floor, leave it on pick walls, and then just hover near the outside face and press tab, so I can select all the walls around the main part in one click, and then I'm going to add in the floor under the fire escape as well, and then just split that edge before I use trim to join those. So I'm just going to leave it as a generic 150 floor for now. So you can see there very simply floor underneath. And then in the level 1 floor plan, I'm going to have a look at the setup for the piers. Now, this is something actually that is, just making sure this is right. I thought the piers were on this side. So I'm going to check that AutoCAD file. Oh no, that's right. Okay. So yeah, so we've got piers here running along the north side. Have you had a chance to look inside this building? I suppose you've only... Oh right, okay. All right, so you should be able to get in and have a look, which would be good. Yep. Oh, great. Yeah, that's great, yeah. So I was going to say, I've got another project. I know someone, well, my wife actually works for a company in the city, and they were offering to have their space open for interiors students to use as a project, and if something good was done, then they were going to use that for the fit out. Yeah, since you've already got a space, I won't use it for this one. So I'll give you this though. This is how it used to look. So it's probably a bit different now, but at least give you some idea what those interior spaces look like, particularly the roof structure and things like that. So it's just called, what was it again? Go away. Venue Boltwell Draper, which is what it used to be used as. So I'll give you that file as well. Okay, so you've got that. It's a PDF file, but you'll see the photos in there, and you've got the facade as well. Might help you a little bit. And the floor plans are a little bit different to what you've got now, but again, it might give you some idea. So, so in the this isn't in those photos either actually, but you could see the trusses there. So you've got these trusses that are exposed, that sit on the piers, and actually, so you can see some of them there. Go away. Okay, so let's just see there. So you've got these exposed piers, which aren't shown in the floor plan, but you can see them pretty clearly in that photo, and not in this one, but maybe in some of the others. No, I think that's the only one actually. So there. You've got those, and they will at least give you the position of the trusses. So we've got that shown in this floor plan, these truss positions, so these pier positions, which again give us the trusses. Okay, so you can use the grid tool in Revit, and so again, I'm going to base it on the walls that I've drawn there, and I'm going to start with a measurement from the AutoCAD file. So that's 200, and I better show you the truss. Okay, so that's the truss family, and I'm just going to show you in plan and check myself what the dimension is. Okay, so that's 100 wide. Alright, so I want this truss to sit up against the wall, that end truss. So I'm going to make the grid line there 50 mil from the wall. And you can do this in either it's best to do it in the level 1 plan. So I'm going to just make my grid. I'm going to delete the other one. So that should be number 1. And then I'm going to make sure that is 50 mil from the wall. Before I go and check now what the distance should be to the next one. So I'll just check corner to corner. So 2839, that's not great. 2459, what about? Yeah, so none of those dimensions really make much sense. So here, 27, it's going to see again if I measure between the next 3 metres and 3 metres. So once we get past the end bay, and this is pretty standard, the end bay is going to be different to the others quite often, then it becomes a more usable measurement. So I'm going to copy that grid across. You could always draw a new one, but sometimes it's easier to copy them. When you select it, you can just click the copy button, pick it up on the intersection there, and then bring it across. I'm going to select my new one, and then make sure it's dimensioning to the grid instead of to the wall. Let's see if I just can't make that dimension a little bit more rational. 2772. Well, I don't want to move it too far, so I'm going to make it 2770. I think that's the best I can probably do. And so now, the others should be 3 metres, so I can use the array tool and then just, well, here I'm going to leave group and associate on. If you've used array you've got that option usually turned on, and that'll give you a group of objects. I'm going to leave it on, even though afterwards I'm going to ungroup it. I leave it on, then it'll give me a chance to adjust the number in my array until I get it right. So 6, that's not enough. What do I need? 10? Oh, sorry, too many. 9. Okay, so now I can select all of those, and an easy way is just to select one, right-click, select all instances in entire project, and then I can ungroup. So I don't want to keep them as an array or as a group of objects, especially because I want to go and adjust this last one now. So again here I'm just going to try and measure from there across. Yeah, so it's better to set it out from the wall anyway. So I might go back to one of the other floor plans and just try and drag that away, and then get my dimension to measure from this wall here, 50 mil. So that should, on the level 1 floor plan, be 50 mil from the inside of that wall, and that should work pretty well. So then I'm going to have grids going the other way, which aren't as important, but it's going to have at least the center line. So you could have the grid tool, in this case, just set to either the inside or the outside face of the wall. Doesn't really matter, so it's not as important. I'm only really doing a grid this direction because I've got a grid going the other way. So just making the grid here A. The next one is the important one, following the reference plane, and then maybe just again on the inside face of the wall. Right, so now I can easily put the trusses in, and I'll do that going to the top of wall floor plan, and then can just go to, well actually I don't even know what category. I'll probably just use generic models for that truss family. So, I better show you where it is. So I'm going to go to open. Were there trusses there? Yeah. But yeah, I mean you can use anything else from there. But yeah, so this one, if you don't know the category of a family, you can just open it and then go to here, family category and parameters. So you can see that one is generic models. It's okay as long as you know what the category is. And then if you click load into project, and I haven't even saved it, so project 2, and space to rotate it, and then it should be able to snap. Well, first I was going to snap it up against the wall, and then I'm going to check the width. And now this one's a bit strange because we've got a box gutter that's set down, and I'll show you this in AutoCAD. So the truss, yeah, it didn't go all the way because we had this box gutter set out from the inside, and in this, yeah, so it's different on each side. So on this side, the box gutter is completely inside the wall, but on this side, the box gutter sits on top of the wall. Okay, but luckily in Revit we can work this out in 3D, or just in section. So I'm going to draw a section now through the building, bottom to top. Have a look at that. Yeah, so, so we've got the piers, that's right. No, I always forget this. So that's looking the same way, I think. So that truss well, I might go and adjust the family. It's probably a good thing for you to see. So I'm just going to go and check the width there is 14,515. So if I select that truss, and again back to edit family, and so we've got a dimension there, 14,320. So if I select one of those reference planes, and just think about this a bit. Yeah, it doesn't matter, I'm going to have to adjust the joist anyway. So, okay, so 14,515 is my overall width. And now I can simply stretch this and might lock it this time, so that if I change it again, then it's going to happen automatically. And so then I'm going to check this time the distance from the end of the truss to the start of the joist, which is basically 150. And now I can adjust this extrusion, making sure I keep that angle. So I can just move that all across. And luckily Revit will keep it joined usually anyway, which is one nice thing Revit does for you. Okay, so then over on the other side, check this distance. So 400. That probably is already okay. Yep. Okay, so that's pretty spot on. And now I'm going to adjust the chords here, so that can all be moved as a group, I think. That's got to be, now sorry, watch out for that. So notice that reference plane there is pinned because that is the one of the planes that was set up initially in this family, and it's pretty important that you don't move that around if you're working in a family. So I'm going to leave that one where it is and just move the solids, and I can still pick them up on the on this intersection here, and then coming across, trying to line it up with those points there. It's actually a bit difficult, so what I'll do to make life easier is draw in a new reference plane.
Aren't you just moving the middle portion and that small section to the left and not that one?
Which one? The
Aren't you not moving the one to the right because it's where it needs to be?
oh no, they'll probably all need to go. I mean, these are pretty arbitrary anyway. They just hang. Well, they're not structurally correct. They are structural, but they're not in a truss. Those vertical elements, that was something that was done in the old days, and now they've worked out there's more efficient ways of doing it. So the position of those wouldn't be that important as long as you're showing it graphically in your drawings. So I'm just going to use the move option there and bring this across, and then go and adjust this chord here and use the align tool. And then the same with these. Probably didn't need to do these like you were saying, but it doesn't hurt. Alright, so that should be close enough. And so I'll save that again, but you can always go and adjust that if you need to. And load it back into my project, and then overwrite the existing version, and that should then fit better. So I can move that back across now. So at least fits between the walls, and then you've got to remember that this wall on the right will come up, and there'll be a box gutter sitting in there. This wall on the left comes up to, well, it still comes up to the top of the truss, and then the box gutter sits on top of that. So you might be tempted to bring that wall up, but remember this level is for the top of the wall, so the truss should come down. So the distance there is 250. So the truss should have an offset of 250, minus 250, so that it sits down with the top of that beam, the top of the, sorry, that's actually the cord, but anyhow, the joist really, I suppose it is in a way, sits right on that level. And then this wall will come up higher. And you could even have make a guess at that, say 300 or something. And so by getting that truss exactly right, then you should be able to simply copy that in the top of wall floor plan using the copy tool, and then you can tick multiple and just copy that using each grid line to snap to, and it should line up exactly. Okay, so that should give you a good outline of the building's rough overall form. And then so then also though, over here, you can see that the truss isn't sitting on anything. Here we're just going to assume it's engaged somehow with that wall. That's what it must be in reality. But over here we know that it's sitting on some piers, and so you need to put those in as well. And I'll show you a good way of doing piers. So you'll see there are tools, all sorts of tools for doing columns in Revit that are pretty good. But I've found from experience that if you need to do a pier like this that's engaged with a wall, sometimes it's easier just to use a wall. So we know here that is 120 by 380. So this one here should be also 120. So I'm going to go and make a wall, set it to top of wall, and then the size I'm going to make, duplicate, 120 for the thickness. And then, what was the do you remember the thickness of my beam going across? Was it 250? I can measure it here. Actually, this is showing you a good thing. A lot of people will try and bring sections and other views like that into Revit to work off in the section view, but often it's easier just to have it open in AutoCAD if you've got an AutoCAD version, and just go in there. If you're just using it to measure off, yeah, it is, yeah. And you don't have to worry about what's happening in Revit, so yeah, it makes life easier. So here, I can set the top offset to minus 250. So it's going up to that top of wall level, but it'll be 250 below, which means it should sit underneath each joist. And so here, I'm going to leave it on finish face exterior. Yeah. And then draw from there back to the left, but I need to press space to make it flip the other way. And you can just do that along over each one. You might need to use join to join these as you go, but otherwise I can copy these. If you really want to be fussy, it's only a pier, but if you want it to be fussy, you could get that dimension to be an exact distance either side of the grid line. I don't think it's really going to matter though, because you're probably just going to cover these up. And the most important thing is that the grids are set out accurately. So you can see there I'm just copying. I've got multiple still ticked from before. So copying each of these. Again, snapping to the grid lines. And I might draw a new wall in for the end. So now back to here. If you've got the hatching turned on, then they'll read as one anyway, but when you go to a fine or something like that, medium display, then you might need to use join again to clean up the geometry. So that shouldn't take long. You can use multiple join here if you've ever wondered about that multiple join option. This would be a good classic case where you could use it to save you a bit of time, but otherwise it shouldn't take long just to choose each one. And so then in 3D view, we can see then we've got piers sitting nicely under the trusses, and that could be a good detail to have exposed in your space if you wanted to give some idea of the existing structure. Up to you, but then otherwise you'll have a floor separating the two levels, which I can just quickly put in now. So I'm just going to use the floor tool again on level 1. Pick the inside face of those walls. So don't make the structure too complicated if you don't have to, and for existing floors it's fine just to have them sitting inside the walls like that. And here you could say no, definitely don't say yes, say no to this, because you don't want those outside walls to stop at the bottom of your floor. It'll look really messy if you do. And so there we are. So you can see the walls there not attached to the floor, and if they were, we'd have a gap between our two walls. You don't want that. So looking in the section now, looks reasonable, but one last thing I'll show you to make that a bit more presentable is to have these two floors. I'll make a new floor type, and use duplicate again and just say existing. Let's just keep it 150 mil. I'm not going to change anything about the structure, but I'm going to change the coarse fill pattern and just make that solid. Just so it reads a bit better in the section. The grids here, we could just bring them up a bit so you can see the truss. And oh, sorry, I meant to show you the roof. So really the truss there is mainly being brought in at this stage so that you can set up the angle for your roof. So looking in this section view, you can clearly see the pitch. And if you want to, you can try and measure that using the even just the angle tool there. And so you can see the measurement for the pitch is 17.874, and that's probably not even completely accurate, because it's taken from the distance across and then the distance up, which is of course basic trigonometry, and that will give you the angle. In other words, a gradient, rise over run, will produce that angle, and it's not always going to be a rational number. Quite often it will be a number with never-ending decimal place or never-ending decimal points. So if we cancel that. Okay, so in that situation, it's easier to use roof by extrusion than trying to use roof by footprint and working out the angle. Okay, so have you used roof by extrusion? No. Yeah, so it's really useful actually in situations like this. You can just go to roof by extrusion and it'll ask you to choose a plane. So we could actually use one of the grid lines in this case. You just need to make sure you don't delete this grid line. So grid 1 I'll use. Click OK. And then it'll ask for a level. So it's attached to both of those things, the grid line and the top of wall level it's going to be. So I'm going to make sure I don't delete those things, but it should be okay. I don't think I'll need to delete those. And so now I'm just going to use pick lines and pick the two edges of my truss. So that's the roof shape I'm trying to create. It's a fairly simple roof. Basically, it's the roof lining. And we can even see that here. We've got the sarking, the foil there, essentially, exposed. And then the roof lining would be right on top of that. There might be some battens, actually, in there, and maybe some insulation, but I doubt there's even insulation there. It's probably just the battens. And no, actually the battens would go this way, so no, they probably aren't even battens. It's probably just straight onto the roof lining. It's a bit hard to see there. Yeah. So anyhow, we just need to have a rough idea of that structure, and so 400 mil is way too thick. Just going to go edit type, duplicate, and we'll make it. Let's just say it's corrugated. So, do you know the proper name for the corrugated profile nowadays? Yeah. Custom orb is the profile that's used by, BHP. So, yeah. So you can't go and just buy corrugated usually, but well, if you buy it from One Steel or the companies that branched off from BHP, then custom orb is what they call it. And then, yeah, there are variations on that. And yeah, it's just a type of corrugated profile. So you could call it custom orb. And if you want to look up how to draw an exact profile, then look up that on the LifeSarts or the One Steel catalogue, and you'll find exact, probably AutoCAD files where you can just draw that up. But I'll call it corrugated for now. We'll look at how to do a custom orb profile later. So we go to edit that, and then the thickness is going to be very small. It's about 50 mil, but just so it reads a bit better in the drawing for now, I'll make it maybe 70. Click OK, and tick to finish. Done. Oh, now sorry, there it's gone down because it's a roof. Okay, so roofs always go down, and so I'm going to go back to edit profile, and I'm going to move this out by the thickness. And an easy way to do that is using the offset tool. Turn the copy option off, and then just put your distance in, so that's going to be 70. And basically I can use that to move those two lines 70 mil away from my truss. And it's going to overhang slightly, but that's okay because the line here will bring it back to the joist. Sorry, the rafter, really. So, and that will that'll read properly. So that's. Oh no, sorry, it won't go automatically. We have to change the beveling, but that's okay. It's all right like that. So at least it's sitting on top of the truss now. But in 3D, we'll see that it's probably not the right length. By chance, it's actually turned out pretty close, but I better show you how to adjust the length. Back in maybe my site plan view, I can select the roof. I'm going to bring it back using the arrow here. And so this is the final thing about roof by extrusion. Obviously, in your section or elevation, you draw the profile, which is just a single line. It doesn't need any thickness, remember? And then in plan, you can change how long it is. So in this case, we've got a parapet at the front and the back. So the roof needs to sit inside the wall there so the parapet can rise up. And so if I go to that elevation now, I could even select that wall on the upper level, edit profile, and maybe using pick lines, put in an offset value there. I'm just going to guess. Oh no, so I'll even maybe take a measurement from the AutoCAD file. It's going to be rough no matter what I do, so let's just do it very roughly. I'll even turn snap off here. Yeah, 250, something like that. Okay, so I'm going to put that offset value in here on the options bar while I'm using pick lines, and then I can just pick the edge of my roof. And yeah, I think I'll just delete that line for now and trim just so you can see a simple way of getting a gable parapet. Be the same at the back, but we'll have a look. The back's a bit funny, so that'll be enough at least to give you the facade or starting point for the facade. Actually, just while that's happening, do you know what to do about the ends if they don't join? See how here you've got these other walls extending to the corner instead of this one? Do you know how to fix, or do you remember how to fix that? So, sorry? Oh, you can, yeah, yeah. Oh, so no join won't work here because they've got automatic joins. So that join geometry tool only works where things aren't already joining. But these are walls, so they've got automatic joins at the ends. So what you can do is use the wall joins option next to join there, and then click onto that corner. It'll highlight it with that square. And you can see there, that line there shows this wall extends to the end. So if I go next, it'll change it so that this one extends to the end instead. Yeah, really useful option. So here again, I'll choose this wall, and we can see the same thing, this wall extending all the way. So if I go next, and next, there's a few different options for this one, but now that one extends all the way. Because we've got 3 walls there, we've got a few different options. Okay, so then back to my 3D view. That's fixed it. So that'll give you the shell. You'll need to have the box cutters in along there to fill in that little gap, but I'll show you that later. Notice how we've got a few little things happening because I changed the wall joins, but the wall join tool, so the regular join tool should take care of that. So that should give you the shell. And then the last thing I'll just mention there is the transitions between the levels. In other words, the stairs are set up like this in the existing building, but I think you're going to be probably changing that. I think for most of you, your design is going to determine how the stairs work. So you might want to leave the stairs out, but if you do want to keep the existing stairs, you've got them in the floor plan there. And of course the fire stairs there, you can have a look at those. But of course, until you do that, this floor is going to block any views between the 2 levels. And also, I know I said the final thing a few times, but there is one last thing. So these trusses, they should be true trusses. In other words, they should be able to span all the way. I don't see why they couldn't, but I know in the past a lot of people were worried about removing that centre wall completely and kept columns. Right, so you've got there, it's a fairly big span. Yeah, 14 metres. So you definitely couldn't have beams and things like, well, you could have a beam that spanned all that way, but it'd be a big beam. But in theory, the roof should be able to cope with the that span because of that truss. But maybe that's something you've got to check with Jeanette as well, whether she's going to allow you to consider that to be a true truss. There is every chance that it's not. That it's an old roof structure that isn't capable of spanning that distance. So just see what she says. She's essentially the structural consultant for this project as well. I mean, it's funny, it would have been one building originally, and then it was broken up into two. So I think there's a good chance that the roof can span all the way. So, and that'd be nice if you don't have to have columns. You'll still need things to hold up your floors anyway, if you're going to have voids and other things. And yeah, so maybe the ceilings we'll look at later, but if you want to have a go at doing a raked ceiling, remember you've got to use model in place. And yes, I'll do the massing later as well, but maybe do that next.